Hello and welcome to P Guru's channel. I'm your host Sri Iyer. Today I am joined by Dr. SHIVA Ayyadurai, who's running as an independent for the Senate seat of Massachusetts. He's pitted against Democratic Senator Elizabeth Warren, and you can tell me what the name of the Republican senator is. The hangout today is about the art of invention. And that's something that I share in common with Dr. Ayyadurai, and I have very pleasant memories of how a light bulb goes off from there on to how you make it wildly successful and improve the lives of human beings. So to hear about his experiences, and I want Dr. Ayyadurai to delve. Maybe you can pick the ones that impacted you the most and also created the most impact on the society, because you have a body of work to speak from, and I would like you to share with our viewers what are the things that impressed you, that hey, there's a problem here, I want to solve it, and basically how does the idea germinate in your mind? If you could share that thought process, that would be excellent. Thank you, sir.
Yeah, it's a great question. So I think there's a notion of invention and then the notion of innovation. So we should talk about both. But I think, let me give you sort of the overview of this. I think ultimately anything that is created or innovated or is a dualistic process between the person doing the creation and the fact that there's a problem. You're always solving a problem. None of this occurs in a vacuum. So that's really the collaborative process. So you can have a single inventor doing amazing things, but there always has to be a problem that needs to be solved. And so part of it is, you're trying to identify a problem. From an economic standpoint, some of these problems have huge, economic opportunities, and others could be as simple as the fact that you have a drippy faucet in your home and you need to fix that, right? And you find some clever way to do that. So the success economically doesn't always correlate to the invention, right? Because some people have done amazing things, but it doesn't get out to the public. So, but ultimately it's about solving a problem. So I thought I'd give, and obviously we can have a conversation, sort of three, I think, extremely important innovations, which I've been personally involved with. One as a single inventor in the case of email, one with Echo Mail, which was my second life with email, very different. It seems I couldn't get away from email almost 20 years later. And then one with Cytosolve. And I'll talk about each one of those. Is that okay, Sri? You want me to go through each one?
Absolutely.
Yeah.
You have the floor, sir. Yeah.
Yeah. So I think when you look at this, in 1978, this was the problem at hand. Computers were just coming. Most of the computers were huge mainframe computers. The people who used computers were elite academic scientists. They typically wore a lab coat. They had pocket protectors, and they were using computers for scientific computing. The notion of using computers for business applications or application programming was very, very new. So think about that environment. The notion of a secretary or an everyday person even getting access to a computer was inconceivable at that point. So you have an environment from a computing environment where the iPhone today probably has thousands or tens of thousands of more computing power than the mainframes of those days. Here's the business problem. In those days, how did people communicate? Obviously, they had the phone, but the problem was in large organizations, the way people communicated was through paper. Paper was a form of communication. And in particular, that was instantiated in something called the memo. So there was a fundamental...
just continue.
Right. So in those days, it was physical paper mail in the inner office environment, different than what you got at home, personal mail. But the problem was that it was a very, very time-consuming task to literally create a memo, particularly if you had to use that memo as a vehicle for collaboration. So for example, if you were in one of these office environments and you were going to hire someone, well, you would get their resume. I would perhaps interview them. And then if I was a hiring manager, I would put together a memo to maybe 10 or 20 people. I would attach that resume, give the subject and a little cover letter, and that memo would then get forwarded to different people on that list, and then they would give back their comments. It would come back to me. I would look at all the comments, and then I would make a decision. Sometimes you have to go back and forth. So you can imagine if you had 10 people, when you wrote that memo, you would do what's called a carbon copy. The carbon copy paper is typically a paper in between another carbon paper and a paper, and you would type away. The secretary could be typing all day long. If there was a mistake, you'd white it out. You had paper clips. You had filing systems, an inbox, an outbox. Sometimes you archived the attachments and the resumes and things called folders. You had trash cans. Sometimes you wanted registered mail to make sure someone actually got it. You had the concept sometimes of broadcasting mail. So these were all very, very time-consuming tasks. So here's a dual problem that I was presented with. First of all, you have secretaries who've never seen the computer. Think about that. They've never seen really a keyboard. They've never seen a screen. So, and there's a cultural context here where the doctors, there was a class hierarchy in some sense. The doctors always looked down upon these women. It was a sexist environment in some sense. Women were relegated always to just work on their desk on these typewriters. And on top of that, you had the fact that computing itself was inaccessible. So the question is, if you were to create an electronic version of this very complex system in the electronic format, how do you do it? So as a kid, you know, that was a problem I was presented with. And as a 14-year-old kid, you know, by the way, at that time, prior to that, there had been the experts, and all of this is documented, which we found, they thought doing this problem was impossible. The RAND Corporation had written something saying, well, you know, there's too many pieces here. You have people of different user experiences, you know, secretaries and high-end people. How do you create a system, which means a user interface, what we call it, that could accommodate a variety of users? It's not a simple problem. And I never thought it was an impossible problem because my customers here were secretaries, and I dealt with them. They were everyday people. I went to the cafeteria with them. I ate with them. They considered me, I mean, a kid, but they considered me a fellow worker. So the first thing was really getting your hands dirty and understanding what the real problems were. Well, first, the problem was, well, they've never seen a computer. So if you're going to build something, the interaction with that computer better be really, really easy. And it better mimic the actual items and objects that they were involved in, and it better have all of it. So you can't have, they were used to having an inbox and an outbox. It couldn't just have an inbox. It had to have the inbox and the outbox. It better have attachments. It better have carbon copy. It better have blind carbon copy. So what I'm saying, Sri, it needed to have all of these components because it was like a complex system where you couldn't give them a car and say, oh, by the way, we left out the steering wheel, okay? Because they were used to that. It may seem simple, but it had to have every one of these parts. And when I itemized that parts menu, I think it's in the Smithsonian, it's up online on inventorofemail.com. I think it was close to about 100 different parts of a very complex system. It wasn't just simply exchanging messages. So all of those parts, that was one piece. Now the other interesting piece was, so by the way, I went off and programmed all of this, built it, and you had other limitations. You only had 8K of memory. I had to write.
What was the computing environment you built?
It was a Hewlett-Packard RTE4 operating system. Mini computers were just coming, HP platform. We had a database library. So this was done in a database. In many ways, it was more advanced than what we even have now. And one of the constraints that we put on ourselves was the system had to be bulletproof. It couldn't go down. We didn't want to, we had a very interesting constraint I put on it, which was you should never have more than one copy of an email. It's a very interesting constraint because of memory. So when I wrote you an email, there was only one copy of it. Unlike today, there's and everything pointed back to that copy, which means it was a very efficient system. Again, with memory constraints, you do these kinds of sort of very smart things.
Right.
And it was hierarchical, it was searchable, easy to use interface. And now here's the interesting thing. No matter what we built and how great it was, there was a cultural problem. The doctors, I remember having this conversation with the doctor. He goes, why are you doing this? Why do we need this? Why do we need this system? And his view was, I just go to my secretary, and this is the way they used to do it. I dictate to them. They type it up, they put it in the drafts folder. I come with my red line pencil, I put it back, and the next day my letter's done. So the doctors were concerned that even with why was this necessary? Because they essentially had their carbon robot, right? Which would do this for them. So this was an interesting problem, right? To explain to them that you should, because, you know, for them, it's now you have to train the secretary. So there was all this other stuff which we forget in the innovation process. An inventor may just build that code and think it's done, but beyond just the code and having all these features, I had to write a user's manual. I had to set up the training environment, right? I had to build the training. I used to hold, in those days we didn't have PowerPoint, we had literally plastic view graphs. So I, as a 14-year-old kid, 15-year-old kid, would hold the training sessions. And I had to handle customer service. You know, trouble tickets, literally. All of this is what this 14, 15-year-old kid learned in 1978. Now, was it commercialized? Because one is inventing it, one is getting it used, and the other is actually commercializing it. And we did, in fact, do that because in those days, we didn't have shrink wrap software. We didn't, in some ways, it was the local area network. This was all in the cloud, per se. People are physically connected to these. There were 3 mainframe locations. It was a network. But the important thing was in those days, what was emerging was time sharing. So when you got on the computer, you paid a fee, X per minute. Well, this application was one of the first emerging applications. And there was a separate tool that one of the other colleagues had built called Charger, CHRGR. By the way, in those days, all programs only could be 5 names. This was written in Fortran. And this was called email. A term like that had never been created.
5 letters in a name. Okay, got it.
Yeah, the term never existed because Fortran allowed 6 characters for variable namings. The operating system only allowed 5. So again, not only did I create the software, not only did I name it, but then I also had to make sure this name was known. I mean, a term like that had never been used. And then later on, it was only in 1981 when I went to MIT, did the president of MIT say, Shiva, it's too bad, you can't patent software, because he was science advisor to Reagan, and he said you should copyright it. So that's where I learned about IP protection, that you couldn't patent it. So I had to write for all the forms. There was no PDFs. You wrote away, you waited, you paid your $10, you put in all your code, and you made it now publicly accessible to the world. And on August 30th, 1982, I was issued the copyright. Now, I continued to work on this, but, you know, the university obviously, you know, I don't know how much money they made, but people use this application in that university environment. So that's an example where we looked at a problem, which is this very complex paper-based system. We had customers, we had early customers, so we worked in small groups of customers, got them happy, and then we expanded. But to expand, it's a different set. It's not just the tool anymore. You have to get buy-in from your stakeholders. You have to address their concerns. Oh my God, my secretary is going to a training session, right? I have to have her do this. So you have to convince them. There's a sales piece that what you're doing is going to save them long term. So all of this.
I have a question. How did you manage all this while you were being a student at MIT?
This was in high school.
Oh, so you took a break from this when you went to MIT?
No, I was doing this while I was in high school. So so I had finished my calculus. I had no more math courses. I finished all my science. I had some English classes left. So I could have dropped out, which probably would have been, in retrospect, something even better. But I had to finish some, I think 2 or 3 humanities courses per semester. So I would literally leave high school and go into, sometimes with a bus, sometimes my mom would drop me off 30 miles away into Newark, and I'd work full time, and then I'd come back. And the first year I didn't get paid anything. The second year I got paid $1.25. First year they gave me free food, and for a kid that was pretty big to go to the cafeteria with the older people and eat. But I would walk in with my briefcase. My mentor said, Shiva, I will treat you as an equal. We will never consider you a 14-year-old kid. You just have to show up to work. Here's your desk. You have to behave professionally. And I was a super professional. I worked 16, 18-hour days. Sometimes in those days, he would give me a big, laptops weren't there, where you'd have a, you know, Jesus, I think a 1200 baud modem, which was considered fast.
Right.
Okay? So
I've used them, I know.
yeah. So, but here, the ecosystem for innovation was an interesting one. That lab had around 6 people. The mentor there had a vision of creating bulletproof code that was user-friendly. We had my school teacher who had fought with the administration to change the rules. She saw something in me, and my parents. That was the ecosystem here. It wasn't venture capitalists. It wasn't, you know, tons of money. It wasn't the military. It wasn't MIT. It was in that ecosystem where email was born and also scaled to meet that environment. Now, had Newark been embedded in Silicon Valley, right? Or with a lot of capital, it would have probably been a very different thing, because I would have had parents. Bill Gates' father was a lawyer. We didn't have any of that, right? We never even, by the way, thought about making money. We were open. IBM and HP used to come into our lab. They saw everything. We never made people sign NDAs. So people always wonder, well, how did that innovation become what we have today? Well, you know, we were pretty open. How did the Wright brothers airplane become the Boeing 747, right? Well,
right.
So, you know, but anyway, the bottom line is, this is an example of not only an invention, it was used and people paid for it. So it went through the entire life cycle. We had to serve. I mean, the biggest thing you learn is solving bugs and customer service, because this is a new thing for people. When you have something new, people always want to go back to their old ways, right? Well, what's wrong with paper? My typewriter works. It's easy. I have to learn this other skill. So you're always competing with that whenever you offer a new tool. So that's email. Now, fast forward to 1993. I came to MIT in 81, went in and out, did a bunch of degrees, electrical engineering and computer science, then went, actually was a founding engineer at a company which we did the predecessor to PowerPoint for Lotus 123. That company got sold to Lotus and then to IBM. Came back to MIT, did my master's in mechanical engineering and another degree in visual studies out of the Media Lab. And I was starting my PhD in a field called pattern analysis. I was starting to develop a platform to analyze all different kinds of patterns, be it voice signals, be it ultrasonic signals, handwriting. And I realized across all of these, what we today call AI type problems, they all were using the same underlying math. And I was building essentially an Uber way of using a platform to analyze many different kinds of problems. In the midst of that, in 1993, people may remember the internet, by the way, email had been in the office environment, right, 78 to 93. But in 1993, people may remember something called the World Wide Web came, which was literally the user interface to the internet, a graphical user interface.
Mosaic,
Mosaic, etc. Netscape and all those guys came. Now, as a part of that, the old inter-office email, by the way, you don't need the @ symbol, you don't need the internet for having email. This is a big myth. A lot of the 20-year-olds on Wikipedia simply don't understand this. And you used to have local area networks. We used to use the dot. Other people use @ symbols, exclamation. But the point is, when the internet or when the web came, people started translating the inter-office email programs into the web-based version, Hotmail, Lotus Notes, right? Gmail, Yahoo. And that occurred because of the web. So you have the web come, and on top of that, people started building web-based apps. One of them was obviously email. And email volume went from probably 1 million per year, and it started going like this, right? Explosively growing. So I was in the midst of my PhD, and one day I got a call from a friend of a friend who was working with the executive office of the President of the United States in the White House. Now, Bill Clinton was in office then, and the White House is receiving, their number of emails are starting to grow. Remember, government was always used to paper. You would write to your president, and the way they handled paper was at the White House, they had 147 different categories, and they had form letters for each one of those answers. So if you wrote in a letter to the president concerned about education, they said, oh, education, pick up the form letter, sign it, and send it. Well, when email volume came, now this was explosively growing. They had no way to handle that. They were using interns for that. And so 5,000 emails per day, Sri, is what the email volume is starting to increase at. Well, you can't hire enough interns. Bill Clinton may have liked that. I probably should use that in terms of putting together. But
I was good. I was waiting for that. Go ahead.
But anyway, so the issue was the Office of the White House runs a competition to see, are there technologies out there that can take an email. By the way the White House was doing email, they would take an email, print it, treat it like a physical letter, and they would write back a physical letter back to an email, and so you had to include your address. Very, very archaic process. So they were looking for ways, when an email came in, could you automatically categorize it into 147 buckets and tell them which form letter? So it's a field called cluster analysis or pattern analysis, and that's what I was working on. Long story short, I end up winning this contest. I beat 6 companies, and I was just a graduate student. My attorney, who's still my attorney now, he's about 85 at that time, John said, Shiva, you could always finish your PhD, but you should go start a company. Otherwise, if you continue working on this, some MIT may try to claim ownership. So I went to MIT for whatever I had, and I asked him for what's called a waiver, and MIT didn't think this was going to be it wasn't going to go anywhere. So I left MIT, much to the chagrin of my parents, because it takes a lot to get into a PhD program. Left, and I had no money, and literally I said, who would want to buy this tool? And fortuitously, I met a guy literally when I was setting up some servers, and he said, hey, Shiva, I just got AT&T as a customer. We're going to be doing their web development. This is now 94, 95. Remember, websites were new, and he had just sold AT&T the concept of building across all their businesses, and AT&T had agreed to invest $10 million. And Tom's still a friend of mine, Tom Zawacki. So Tom said, I believe they're going to build websites, about 40, 50 websites for all their business units, and every business unit is going to have a contact us form, which means people are going to write in. Okay? So how are they going to handle that? So so again, here's a problem. We could see the emergence of problem. There's going to be high volume of emails. In some ways, we're a little bit early because they weren't even getting those emails yet. So I went to the head of marketing at AT&T who owned all these websites. I still remember the woman, Lisa Gillingham. And net of it, I had to make 40 trips. And I used to take the Fu Huang bus for $15 down to Basking Ridge. Back and forth. Finally, we convinced her that this was a necessary tool, because as they launched those websites, they were starting to get email. And they said, oh my God, how are we going to handle this email? So this is how we launched it. We had all the code ready. We built it. And the issue was that the IT people at AT&T said, we don't want to host this. I mean, right, this is another project we have to do. Right. So I said, you know what? How about this? We will have a server in Cambridge, and you send the email to us. So when someone fills in a web form, right, when they hit submit, we'll send it as a packet to us. And it'll come to our system, and we provided then a web-based user interface, which would allow their call center people to log in over the web. So what we had to do was we had to set up what's called an application service provider, what you would today call the cloud. And how did we do this? Remember, I bootstrapped this without $0. I went to the mayor of Cambridge, and I said, look, I believe there's this thing called the World Wide Web, and it's going to really help people. In parallel to this, I had started another company to help artists go online. I don't know if you know, I also have a degree in visual studies and media arts, and a lot of my friends were artists, and I'd always felt that the internet could be a vehicle to eliminate the gatekeeper. So a lot of my friends were visual artists. They always needed a gallery owner. So we had in parallel built another company called Arts Online, and I went to the mayor of Cambridge, and he had said, look, go talk to the Cambridge Multicultural Arts Center, and a guy literally gave us an office space around 10 by 10 for free, but in return, we gave them internet access. How did we do that? I wrote a book called Arts on the Internet, and on the back of it, I had advertising, which I gave to MCI. So they gave us a free T1 line. We got the office for free. The Multicultural Arts Center got an internet line. We built their website and maintained it. And in that, and then I went to, and we built a website called Arts Online, and I got Digital at that time to donate us a server. Okay. And on that server, we ran Echo Mail also. And AT&T's emails, remember, multi-billion-dollar corporations' business emails were transported to this little box in Cambridge, Massachusetts. And their call center people would log in. And what our technology did was when the email came in, we would analyze the email and extract out the attitude, what you call the sentiment. Was the person happy, angry, or sad? The second thing is we would extract from the email the type of problem. And there was various types of problems. What did they want in the email to reserve, like a refund, you know, a rebate? And who were they? So we basically did this multi-dimensional analysis of an email, and our system would route it based on routing rules automatically, or it could actually propose a response. So when a call center rep logged in, 80% of the work was done for them. So the cost benefit analysis was it was going to cost them $15 to $20 if you work it out to handle an email. It's not cheap because you have to pay people, overhead, etc. And we were bringing that cost down to around $4, and we were getting 30 cents for every email processed, and $1.83 if we categorized an email. So we basically gave them the AI, and if it categorized it right, we got more value. Okay? So it's a very interesting performance-based model. I got AT&T, then I got Nike, then I got Citigroup, and our business grew without any funding, all bootstrapped. We were up to a run rate of around $6 million. This is before, 1 second, Sri, sorry.
Sure.
You let him off, yeah. Basically, AT&T, essentially, the business problem was they could see, like the White House, email volume was going to explosively grow. So either they just put more bodies to it, or they put a different kind of business process. And the business process we offered with EchoMail was first the ability to receive across all their decentralized websites in a manner that they could still maintain that decentralization, have a common workflow and process, and on top of that, be able to augment that with this very powerful AI. And by the way, now this is 2000, and I'm sorry, it's 1995, 1996. In 1994, the Federal Court of Appeals allowed you to patent software because they felt software was a digital machine. Unlike 1978, when I was inventing email, there was no laws to even protect software. It was only 1980 did they decide that they would update the Copyright Act of 1976, and they called it the the Computer Software Act of 1980 to use copyright to protect software, right? The problem with copyright, it doesn't protect ideas in terms of design. That's why I never made gazillions of dollars from the invention of email, because that's for the literal code. What's that?
The takeaway is every user, whenever they send an email, they see the words CC and BCC, they'll remember you because you are the first one to coin those two things, carbon copy and blind carbon copy. So in other words, we're all going to remember you for our, for as long as we use.
Well, email. Also built the whole system and called it email, even the term email. So what I'm saying is this is hard to believe for people because the conflation that took place from the bamboozling of the military-industrial academic complex is a guy who simply wrote some ways to attach text to the bottom of a file. That's email. They never called it email. That's at best a caveman version of Reddit. Okay?
Right.
It's not email. And the sin here and the lie here is conflating a simple protocol to add text. It wasn't even a protocol, by the way. Conflating that to the system, 50,000 lines of code versus 15 minutes of work, which, by the way, never really went anywhere, okay? Which wasn't used in this manner. I mean, I created the system. So when we say email is the system as we know it today, it's not text messaging.
Right.
It was actually designed for everyday users, not for a bunch of nerds who were trying to just send little did-dat communications, okay?
So back to EchoMail, you were at $6 million revenue. Go ahead.
Yeah, so EchoMail, so think about it. Here, first of all, so what's the innovation cycle here? First, it was an idea. We had an early customer. I had built some very powerful code as a part of my graduate work. You know, fortuitously, here's a business problem with the White House, large volumes of emails. We deliver on that problem, and then we have this opportunity. It's just a meeting of time, right, where the web has come and you have the growth of big companies getting involved. So our early clients were not .coms. they were substantive companies, JCPenney, Citibank. So by the time late 1999 comes, we were having cash. We didn't even need funders. While other people, when the web was coming, there was a dot-com boom. So now we've taken it from an idea with the White House to early customers, and now we have to scale the company. Well, that's a very different process, right? Because now you need to have customer service, you need to have training, you need to have human resources, you need to have a finance department, and now there's pressure to go public. So you're paying lawyers a ton of money. So this entire enterprise of just, solving this little science problem has now grown in to an actual living, thriving business with offices all over the world, right? Customers all over the world, with not just a single server in the Multicultural Arts Center. We now are hosting, paying $100,000 in hosting fees, and we build our own data center in a building I buy. So this thing grew from that little idea to something pretty massive, and in late 2001, we decide we're going to go public, and we fill out our S1 forms. It's a very expensive process. And then a company essentially buys a big chunk of our company at a $250 million valuation for around $10 million bucks. And so we didn't need to go public. And then if you remember, the entire market tanked. So we were one of those fortunate people. We had very few .com customers. We had real major brick and mortar stores who needed email. And here we were making real revenue, and we had $10 million in the bank.
Wow.
So EchoMail went from that entire process. And then I had a liquidity event where I took, quite a bit of money off the table. And it's a very different thing running a company when you have 10, 20 people, and then when you have 200, 300 people. And the difference is you're dealing with people problems every day.
Right.
That's what you end up doing. You're dealing with this guy wants a raise, another guy wants a raise, this guy, all these personnel issues.
Right, right.
And so that's around 2002 and 3.
And they all want to talk to you.
What's that?
And they all want to talk to you.
They all want to talk to you. And your learning develops into a different way. It's about people management.
Right.
In 2003, I was literally walking back to MIT, and an advisor of mine had said, Shiva, you got to come back and finish up your PhD. That's what he was more concerned about. I went away for I thought it was going to be a 2-year project. It ended up being a 10-year project. And by the way, EchoMail, our company, was featured in the Millennium issue of MIT, 2000 issue, as the coolest company in Technology Review, right? Tons of press. So when people say, oh, you're looking for, fame or from the invention of email, I never even thought about that. EchoMail was a huge thing that we done. A lot of people knew about it. We made a lot of money, and we're pioneers. We did the first email marketing campaigns for companies like Nike. We won awards for the first transmedia campaign, email linked to TV, etc. Anyway, really cool stuff. 2003 comes, and there's some new developments taking place. Remember, I went into that medical school in 1978 to do medical research, and then email took me away from that. I came to MIT to do medical work. Email took me away from that, right? And then finally in 2003, I come back, and an advisor says, look, there's a new huge paradigm shift taking place in biology. And in 2003, what had happened was the Human Genome Project had just completed. We went into the Genome Project 3 in 1990s thinking that we knew a worm had about 20,000 genes. And the biologists mistakenly thought the number of parts equals complexity, which means, well, you look at a human being and a little worm, we must have at least 10 times, 20 times more genes. So the assumption was when the Genome Project started, we had about 500,000 genes. Could have even been more, the estimates. Every year that goes on, the estimates keep lowering because they're not finding that number of genes. Excuse me. So every year that goes on, they're not finding that number of genes. And in fact, what ends up happening by 2002 and 3, they only find we have about 19,000 genes. So the irony of the Genome Project was we were putting so much focus on genes, the nucleus, that it revealed that, wait a minute, maybe we're not our genes. And this whole new field of epigenetics develops, which says the genes give rise to proteins. Proteins start interacting with themselves and other exogenous things, and those things can turn off and turn on genes. So now basically biology became far more complicated of not only the nucleus, but the interaction of all these molecular pathways and chemical reactions. So we moved to the understanding the whole cell. And in 2003, the NSF put forward this grand challenge was, could you mathematically model the whole cell? And that I thought was a really cool, challenging problem. So I left EchoMail, meaning it was still running. In fact, when we did our liquidity event, we couldn't go after big companies. We could do small businesses, right? So EchoMail was restarting its own thing. And I came back to MIT. And here we start with the same process again, right? Just like with email, first we are working with a few customers, right? Or trying to really invent the technology. Same with EchoMail. The work with the White House was really to invent the technology. And here was, how do you actually invent something that can mathematically model not just 50 reactions, which people were doing at MIT at that time. And by the way, they were exiting that problem because it got very complex when you try to do more than 50 reactions. Imagine doing something on the order of the entire human cell, potentially millions of chemical reactions interacting. It's far more complex than any problem. It's a very intractable problem. So that's the problem I took on. And again, when I looked at this problem, again, I put myself, because I had the experience with those secretaries, I had the experience with working with people who are actually, you know, handling workflow. I said, what's really the workflow here? And what the conclusion I came to was this was not a biology problem, nor was it a computer science problem. Because the computer scientists were saying, oh, let's treat the cell as a black box. There's an input, there's an output. We'll throw machine learning in. We'll use neural nets, and we'll correlate input to output. Well, the problem is you can do that, but it gives you no conception of the mechanisms that are taking place. And in biology, it's not just input-output. You want to understand the mechanistic understanding. So when I looked at this problem, I said, you know what? This is no different than those secretaries who are working in a collaborative environment. And what do I mean by that? Here, instead of secretaries, what you have is biologists. And what is a biologist doing? Well, in their little silos, they're doing experiments on some aspect of biology. And from those experiments, they're not creating a memo, but they're creating a document called a journal paper, which represents a discovery that they made. And many of those discoveries were biochemical reactions. So if you take a phenomenon like cancer, which is composed of two different phenomenon where cells do not die when they should. Cell death is called apoptosis, and cells proliferate when they shouldn't. So if you look at those two broad phenomenon, well, there are thousands of chemical reactions which represent cell death, thousands of chemical reactions which represent cell proliferation. Each of those reactions are somewhere in the literature tree, okay? So the business problem really is, or the workflow problem is, biologists every day are doing their work, they're publishing, and the issue is no one is taking the effort to look at the published literature, because by the way, in academia, there's no incentive to collaborate. You're incented to get your funding, you're incented to get your tenure, and you're incented to hold on to your data, right? Because that's how you publish.
Right.
So what I saw here was, wait a minute, why don't we create this new capability where we could take the literature for any area, identify the actual the pieces of chemical reactions, step one. Then sometimes the models were done. Remember, these are A plus B going to C, C plus B going to D. They're chemical reactions, stoichiometric models or reactions, which some people had actually encoded into computer programs. So now think about the fact that as biology was going to move forward, you're going to have small little computer programs or models which express some aspect of these phenomena. So now the problem becomes, how do you connect systems of models together? You following me? It's not really a biology problem. It's a problem of interconnecting components which are fluid because biology is finding new discoveries, people are instantiating that potentially in models. So what I ended up creating was CytoSolve, C-Y-T-O-S-O-L-V-E, and it was actually an infrastructure to allow you to interconnect dynamically systems of models that could be located on any server anywhere in the world, knowing those models could be decentrally owned. Because there's no way to build a mathematical model as big as a human cell by thinking you're to monolithically do it. This would be like writing software code where there is one coder and he's trying to do Microsoft Word coding by himself. You follow? You don't do that. You distribute the code. You are so that's the infrastructure we built, and that was called Cytosolve. So if email was the electronic reflection of the interoffice mail system, Cytosolve was the electronic reflection of the molecular communication system. So that was the first part. Now, in this kind of science, again, you go through your adoption curve. But because the technology here could actually be used for pharmaceuticals and medicine, we had to validate beyond the 2003 to 2007 when I built it. I had to spend 7 to 12 to really use this engine to say, hey, I can actually solve a biology problem. In fact, I can model something in here that actually mimics exactly what's coming out of in vitro work, which means in a test tube or in a test tube. And we did various things like that. We had to publish in eminent journals. So that took another 5, 6 years. And only after that, Sri, did we then commercialize it, meaning let's go get customers. And this was a very difficult problem because who would want to use this? It's so new. Here we've created a capability that can literally model Alzheimer's. It can model cancer. It can model all these different things. So we thought, let's go to the clinical research organizations, the companies which help pharmaceutical companies do clinical studies. And just to give you an idea, in clinical research or in pharmaceutical development, it's the way they do it is you, for example, could find a molecule that you think in a test tube, you were doing some tests and you saw it kill cancer cells. So you would go raise $40 million and you would buy a lot of lab space, do those tests more in a test tube that's called in vitro. Then you would go kill a bunch of animals, unfortunately, right? And prove it works in an animal. Then you file with the FDA to get the rights to test it in human. Well, that process, by the way, takes 6 years. And then in another 9 years in phase 1, phase 2, phase 3 clinical studies. And you're crossing your fingers. Well, it's about a 13 to 15-year process.
Right, right.
And most of the stuff that comes out of their side effects. So we thought we could shrink that process by using Cytosolve, just like how we build airplanes today. We don't just throw test pilots in. All of the work is done up front, right? And then we go build a few things in the wind tunnel, like with airplanes, and we obviously don't kill a lot of pilots. Right. So that's what Cytosolve became. And we found out that pharma companies move way too slow. We did get a few of them. We work with a lot of them. It helped us validate us. But what we found was that we could be using this technology to doing our own discovery because it's such a disruptive technology. Why should we wait for these dinosaurs to catch up? It's almost like we've created a new printing press that never existed. Do we want to print for others or do we ourselves want to be the biggest publisher in the world? Now, you actually end up doing both, right?
Right.
So we have one arm of the business, which actually helps people who are doing development. We give them a better mousetrap. But over here, we are now building our own new formulations. So for example, we've modeled all the molecular mechanisms of brain health, memory, long-term and short-term memory, cognition. We went through all the potential ingredients, including in the Indian Ayurvedic stuff that were purported, Western supplements. We modeled those mechanisms. We literally can test them and combine them. And we've literally started creating our own IP in our formulation. So what's happened now is, on the one hand, Cytosolve as a services model, which we generate cash. On the other model, long-term, we're building our own IP, which we can directly license. And we've, in fact, spun out 7 companies, one in the Alzheimer's space, one in pancreatic cancer. In fact, we used this to discover a dual combination drug for pancreatic cancer in a record 11 months, got allowance by the FDA, and then did a joint venture with MD Anderson. So you can see Cytosolve's almost like email in the sense it's such a disruptive technology. Our business model is recognizing that we're sitting on, multi-billion-dollar opportunity here. And the only way to scale it is to create an ecosystem where we could create partnerships and spin off a whole ecosystem of companies. So I think in summary, if you see the common thread between email, EchoMail, and Cytosolve, there's an aspect of invention where you're getting a small pool of customers or you have to convince people your stuff works. Then you're going through the early adoption phase, and then you're actually building it out into a sustainable business. And in the case of Cytosolve, I want to be the first, $50 billion company that's done it with probably 20 employees. That's the goal. where we bring in an ecosystem of partners, right?
Wow.
Because
Amazing.
the technology is so powerful. Yeah. So
go ahead, please continue.
Yeah, so I think what I'm saying is, in the case of email, is a one-man business, if you want to think about it. EchoMail was a 300-person business, and we want to almost bring Cytosolve to a much more new, refined type of business model where we have lots of collaborative partners and you increase wealth for a lot of people.
Now, how are you funding the Cytosolve initiative?
Good question. I mean, I funded it initially by myself, you know, which was valuable. When we did the first spin out, we raised about $1 million in literally 2 weeks. There was a paper that came out in Nature saying if you're going to solve cancer, you have to use cocktails and you need in silico computing. And we were referenced in there as the only technology that could do that. Oh. So just with that paper, in 2 weeks, we raised $1 million and we used that. So it's not like we need, so I'm in the midst of raising actually a $250 million private equity fund, which we will manage and we will deploy across our portfolio companies.
Wow. Amazing.
So that's what's exciting. Yeah. And in the midst of that, we're doing the Senate race.
I think people of your caliber should be in the Senate. I think we have a very homogeneous composition, as I see it, and I could be wrong sitting in the Silicon Valley, but I do see that there's a very homogeneous composition that sits in the Senate, and they are sitting over some very, very difficult, intractable problems, things that are going to affect not today, but 5, 10, 20, 30.
They're systems problems, right?
Yes.
They're complex systems problems, and I know how to solve them. Gun violence is not gun violence. It's a complex systems problem involving a multitude of things where the chickens have come home to roost. On the one hand, we have a systemic, you know, violent culture, right? Where we send young 17, 18-year-olds to go kill other people. You know, we forget that. America, or the American establishment of the military-industrial academic complex is a violent culture in that sense. You have kids who are on antidepressants, and when they come off, they have violence. You have gun laws which exist, which aren't even enforced, right? So what I would do is go back. Let's really do the research. What are these? Why is it in the 1970s when I used to go to fairs, we used to have 22 caliber guns. No one was shooting each other. So what has occurred in 30 years? That people are killing each other in schools. So that you have to go down and solve it as a systems problem, right? And these career politicians and the Elizabeth Warrens do not know anything about this. They basically learn how to lie and cheat for a living. They learn how to take 0.001% of genetic matter and trying to compel people to think they're Native American. This is what lawyers do. Lawyers find a guy who's a criminal and try to get him off. It's about not telling the truth. You know, engineers like you and I and others, if we don't solve something, planes fall out of the sky, right? Customers get unhappy because their software isn't working. We're accountable. So we need people who've gone through that journey. And that's why, you know, when you look at the founders of this country, you know, Washington was an independent. He was a surveyor. He was a businessman. He had to run a farm. He actually had to get up and do work. Franklin, one of my idols, you know, he's a polymath like me. He did numerous things, you know, created the Postal Service. These people saw things as systems problems. You look at healthcare. You know, it took me finally about 6 months to figure the racket out. What we have is a collusion between, you know, big pharma, big hospitals, and big insurance. And then there's these people called GPOs who own their connectivity to all the supply chain. Well, you need to cut that off because they've created such an incestuous system. A $5 bottle of aspirin, 2 aspirin in the emergency room is selling for $50. So the entire cost of healthcare is high. So Bernie Sanders is sort of an idiot, right? If you think about it, he talks about this, but has no, it's one thing saying, oh yeah, I'd like to have a flying car. Well, how are you going to build it? Right? So how are you going to fund it? Can it do it? Right? So that's why we need people like plumbers, electricians, engineers, nurses, people who actually have to do stuff because they're solving problems, real problems. So I hope what I shared with you is, you know, the entire process of invention or innovation is ultimately you're trying to solve a problem. And you're trying to solve it in such a way that it meets someone's needs, be it a secretary, be it call center people, or be it in this case, the entire medical industry with Cytosolve, which has a very medieval way of, you know, discovering drugs. And furthermore, the technology we've created, we're actually looking at ancient Indian medicine from Siddha and Ayurveda, because they were basically multi-combination therapeutics. designed for the individual, right? Because an Indian system, which we have another company, by the way, called System Self, which we should do a show on because it's the integration of Eastern and Western medicine. But the point is, Cytosolve is a whole new way to integrate, to provide precision medicine. It's essentially the basis of that. But in each one of these cases, we had to have a real customer. And you're always trying to find a customer who will be your collaborator, like the secretary was, or like the interns were, or in this case, the actual people who are doing development. And once you have that customer buy-in, that's where you co-create stuff that really works and makes money for everyone.
You know, this is absolutely fascinating stuff. And I think if the residents of Massachusetts watch this video, they have a really good idea who they are voting for, what they are bringing to the Senate. And I want them to make that decision after seeing this video. So we are going to try and promote this via social media in the state of Massachusetts. And again, it will go beyond that, it will go viral or worldwide also. But it was a fascinating...
I think people deserve that. You know, right now, think about it. You have two dunces who are allowed on the debate stage. I've had to spend a lot of money to file a lawsuit just to get the rights of you, everyone listening. So anyone in Massachusetts who listens to this, this is not about me anymore. It's about you. When you use the word homogenize, you know, I've used the tomorrow, Sri, is October 19th, is the first debate that I should be on the debate stage. There's only 3 of us. In 2014, 5 people were allowed on the debate stage in a governor's race.
Wow.
Democrat, Republican, and 3 independents, polling less than me. All white people. So let me talk about racism, because it's a question that everyone's afraid to talk about. The right wing says, oh, don't talk about racism. We don't want you to use racism. And the left wing tries to, oh, no, I am going to talk about racism. And the racism I'm talking about is not only color. It's about what you use. It's about the homogenization, the whiteizing of the full human experience of ideas. It's segregating that to hot dogs and hamburgers. No samosas allowed, okay? And when Massachusetts is 60% interested in multicultural foods, meaning it's independence.
Independent, right.
So there's a picture here by Ben Garrison. Ben did a great cartoon. He's got Elizabeth Warren with the guy we call Dirty Deal, okay, who photoshopped a picture with Trump, lies that he's a Trump chairman. By the way, 80% of the people who voted for Trump were not Republicans or Democrats. They were independents. They were voting against the establishment. Right, so the establishment is so afraid of me that they have to use this Dirty Deal guy to convince people he's a Trumper, which means he's independent thinking, and bring them back to establishment politics. And that's why none of the media here has exposed the fact that he's not the Trump chairperson, that he doctored a photo with Trump. It's to keep this illusion, to maintain the two-party system. I mean, we're the ones who innovated only the real Indian can defeat the fake Indian. That was an innovation. And by the way, we tested different slogans. It was literally, we tested Be the Light, we said Fight for America, and that meme was a killer meme. Our customers loved it. By the way, in politics, what you're creating is the message.
Right.
You know, in software, so the message is what you're manufacturing to see what resonates with authentically who you are and what the people want. And that message was a killer product. And that's why the left and the right are so afraid, because we're representing what I call dark matter. And I don't mean by race. The matter that really matters. The 70% of the universe is dark matter. 60% of Massachusetts is the dark matter of independence.